All right, let's talk about artificial intelligence. You hear that phrase all the time, right? But it's so much more than just a buzzword for big tech. Today, we're going to dive into how AI could become a real, actual lifeline for healthcare in some of the world's most vulnerable places.
But to really get this, I want to start with a question. A really simple but powerful one. Can a phone call, something you and I do without even thinking about it, actually save a newborn's life? Just let that sink in. And hang on to that thought, because we're absolutely coming back to it.
And look, this isn't some sci-fi fantasy. This is real. A report in BMJ Global Health puts it really plainly. The potential here is just immense. We could be looking at a total shift in how healthcare gets to the people who need it most. Okay, so first up, let's dig into that promise. What is the big, optimistic vision for AI in global health? What could this actually look like?
The core idea here is incredibly powerful, because while AI is already tweaking things and making systems better in wealthy countries, that's not where its true world-changing power might be. No, the real game changer is how it could work in places where healthcare systems are totally strained, or maybe don't even exist. We're talking about a tool that could help leapfrog over these huge, long-standing problems, like not having enough doctors or being able to predict when a disease is about to hit.
But okay, hold on. When we keep saying AI, what do we actually mean? It's this huge catch-all term, right? So let's break it down. Let's look at the actual toolkit that's making all of this stuff possible. Okay, first things first. Let's get this out of the way. We are not talking about the thinking, feeling robots you see in the movies. That's what's called artificial general intelligence. And for now, it's pure science fiction. What we are talking about is something called artificial narrow intelligence, and these are basically hyper-focused tools. They're designed to do one specific task, like analyzing a medical scan, and do it incredibly well. So a huge part of this toolkit is machine learning. The best way to think about it, imagine a doctor who's seen not thousands, but millions of cases. That's kind of what this is. By sifting through just massive amounts of data, patient records, lab results, you name it, the algorithm learns to spot these tiny patterns that even the best human doctor might miss. And then there's this other cool tool, natural language processing, or NLP for short. This is the magic that lets computers actually understand our language. It's what allows a machine to read through a mountain of text. We're talking everything from a doctor's messy handwritten notes to dense scientific papers, and pull out the important bits of information. Okay, so that's the tech, that's the theory. Enough talk. Let's get to the really cool part and see how these tools are actually being used out in the real world right now. Some of these examples are just incredible.
So for our first case study, we're looking at how AI is being used to fight a massive global threat, dengue fever. This is a nasty mosquito-borne virus, and it's spreading fast.
And when I say massive, I mean it. The scale of this problem is just staggering. Get this. According to our source material, about half of the entire world's population is at risk from dengue. Half. That's almost 4 billion people. Just let that number sink in for a second.
So this is where machine learning becomes a superhero. In the Philippines, they're using an AI model that gobbles up all this complex data, weather patterns, satellite images, how land is being used. And by analyzing all of it, it's learning to spot the exact recipe of conditions that happen right before an outbreak hits. And what does that do? It gives governments a critical warning, a heads up so they can get ready, deploy resources, and ultimately save lives.
All right, so from predicting massive disease outbreaks, let's pivot to something totally different but just as critical, helping guide cancer treatment. Imagine trying to get world-class cancer advice in a place that doesn't have any specialist doctors. Well, in places like Thailand and India, there's an AI app that uses that NLP we talked about to scan all the latest medical research and then recommend treatment plans. The results are, well, they're really interesting. They show both the incredible potential and the big challenges. In one study, the AI's recommendations match the human experts 90% of the time. Pretty amazing, right? But in another study, that number was only 50%. So it's a perfect example of how promising this is, but also a reminder that there's still a ways to go.
And that brings us all the way back to that question from the beginning. Remember, how can a simple phone call save a baby's life? Well, here's the answer. It's about diagnosing a terrifying condition called birth asphyxia. It's when a baby is deprived of oxygen right at birth, and it's incredibly dangerous.
This is just a brilliant example of using the tech we already have. In Nigeria, some researchers built an app that does something amazing. It uses a totally normal cell phone to record a newborn baby's very first cry. Then the AI gets to work analyzing the sound itself, the acoustic properties of that cry, looking for tiny markers that signal birth asphyxia. If it finds them, it immediately alerts a health worker that this child needs help right now. Think about that. A simple phone, a clever algorithm, and a life is saved. It's just incredible.
Okay, so all of that sounds amazing, right? But, and this is a really big but, rolling this kind of tech out everywhere is not easy. Not by a long shot. The path is filled with some really serious hurdles that we absolutely have to talk about.
And right at the top of that list is a huge ethical minefield: bias. Here's the thing you have to remember. An AI is only as good and only as fair as the data you feed it. So if the data you train it on already reflects our own human biases and prejudices, well, the AI won't just learn them, it can actually make them worse.
And yeah, the challenges just keep coming. First, there's the data itself. Just getting high-quality data to train these models is super hard, especially when a lot of records are still handwritten, maybe in local languages. That's a massive hurdle. Then you've got the basic infrastructure. You need reliable internet, you need electricity that doesn't cut out, things we might take for granted. And on top of all that, you have these huge ethical questions about privacy, who owns the data, and getting consent. And the answers to those questions can be completely different depending on the culture. So you see, this is way, way bigger than just a tech problem. So, with all these incredible promises and all these serious dangers, what do we do? How do we get the good stuff without falling into the traps? Let's talk about the path forward. This quote from the source material, for me, just hits the nail on the head. It says, "The real test, the way we'll know if AI and global health is a success, has nothing to do with how clever the code is. Nope. It's all about whether it actually helps the people it's supposed to help. It all comes down to human-centered design. These tools have to be built with them and for them."
And what does that actually mean? Well, it means doing the hard work. It means you can't just drop in some one-size-fits-all tech solution. You have to truly understand the local culture and health system. It means that every single ethical question has to be looked at through the lens of human rights, and this is so important. It means bringing the communities themselves, especially women and people from these resource-poor areas, into the development process from day one. And finally, it's this idea that data created using public money should be seen as a public good for everyone. So, we'll leave you with this final thought. There's zero doubt that AI is getting smarter and smarter every single day. That's a given. The real question, the challenge that will define its entire legacy in global health is this: as it gets smarter, how do we make sure it also gets wise?